This is video on kinetics of particles. This is fourth video in the series, and we are looking at problems, different type of problems. And so far there have been two videos on the problem. This is the third video. Have a look. First problem says a block P1 of weight 4 Newton is connected to block P2 of weight 8 Newtons by inextensible string. Find the velocity of block P1 if it falls by 0.6 meters starting from rest. And coefficient of friction is 0.2. Now obviously it is applied only to P2 because P1 doesn't touch here. Now ideally you also to assume that pulley is frictionless, this wire is continuous, maybe there is some groove inside, and there's no friction here, string is inextensible. Okay. And these like problems, first job is to settle the tensions. In this same inextensible string, tension, this string has tension T and this string has tension T. Then we have to draw free body of every body. That is, we have to draw all the forces acting on each of the bodies. So you see here, 4 Newton downwards, T up. Here 8 Newton weight, reaction, friction and T. Now for each body we are going to write sigma fx and sigma fy. For this body there is no question of sigma fx because only forces are in y direction. So 4 minus 3 is equal to mass into acceleration. So mass is 4 by g. Now for this body we have T minus 0.2 r is mass into acceleration, and r minus 8 is 0. Now please note one thing, that here we have taken 4 as positive and t as negative. Reason, we are assumed, it has been told to us that it falls. So motion is downward, so all downward force is positive, upward negative. And here we have taken t positive because now here motion is towards right. So all forces towards right are positive, all forces to the left are negative. So T minus 0.2 r. 0.2 r is 8 by g into A. Now with this situation, see, you have a case where in these two, see, R we have worked out. In this situation we have two unknowns, T and A. So by eliminating T, that is just adding these two equations, we can work out A. That is acceleration, that is 2. Now this is going to be same for both because they are connected by a single string. And then we can use our kinematics equation, v square is u square plus 2s. With initial velocity 0, we can work out v because s is given as 0.6. S is given in 0.6. So to answer the question, velocity of block P1 will be 1.55 meter per second after this falls through 0.6 meter. And here for calculation we have taken g as 10 because it was given. Otherwise normally we will take g as 9.81 meter per second square. Okay, let's look at next problem, where the two blocks shown start from rest. The horizontal plane and the pulley are frictionless and the pulley is assumed to be of negligible mass. Determine the acceleration of each block and tension in the cord. First, when you try to settle the tension, you realize that this T goes like this, same string goes around, but here, because there are two T's out here, this becomes 2T. In other words, the block B is being pulled by 2T, where block A is being pulled by T. Let's draw the free bodies as before, and let's call out the tension which pulls A as TA, which is now T, and tension which puts B as TB, which as we discussed it is 2T. Now this gives us TB is equal to 2TA. Now when the tensions are different like this, unlike the previous problem, accelerations are also going to be different, and in fact they will be in the inverse proportion of the tensions. So TB is 2TA, so 2AB is A. So I have these two equations handy for me, and then next we write sigma fx, sigma fy. Now for this body only sigma fy is meaningful, so sigma fy, right, 300g minus tb is 300 the mass into AB, acceleration of B, and for this TA, that is the tension which pulls A, is mass into acceleration. There is no friction out here. Now 1, 2, 3, 4 are 4 equations and 4 unknowns, TA, TB, A, AB. So by simply, they are quite simple equations. By substituting and solving them, we will get all these values which were asked in the problem. Next problem. The 100 kg block A shown in figure is released from rest. If the mass of the pulley and the cord is neglected, if neglected, determine the speed of the 20 kg block B in 2 seconds. Okay. Now let's settle the tensions T, 2T, 2T. Now you see, we have to assume what will go up and what will go down. But the point is, when there are two blocks like this, one goes up, other has to come down. So we can assume anything, and then if we are wrong, all we are going to do is get a negative answer. We'll make a reasonable assumption that A goes down and B goes up, and on that basis we'll write our equations. So here are the free bodies, and again you see, let's assume TS tension pulling A, TBS tension pulling T, so TA is 2TB and accelerations in the inverse proportion. Now sigma Fy equation for B tells me TB minus 20G is 20AB. 20 is mass. Mind you, TB is positive because we are assumed motion of B upwards, all upward forces positive, downward negative. And here, see, A is going to go down, so all downward forces will be positive. So 100G minus TA is 100A. I have 1, 2, 3, 4 and I have 4 unknowns, A, AB, TA, TB. So we can work them out, and our to answer the question, determine the speed of 20 kg block B in 2 seconds. We need B. We need B. And well, after working B, we have worked out acceleration for B. So the speed can easily be worked out really by simply our kinematics equations. That is, V is equal to U plus AT, put TS2 and AB as 6.4, 6.54, and we'll get the velocity. Not written here, but it's just a matter of another one-step kinematics equation. Okay, next. System shown in figure is at rest initially. Neglecting friction, determine velocity of block A after it has moved 2.7 meter when pulled by the force of 90 Newton. Okay, we settle the tension. We realize that TB, that is tension which is pulling B, is this T plus 2T, that is 3T. TA is 2T. So we establish relation of TB and then acceleration, and then we write for this A 90 minus TA. See, TA is this, okay, is 22.5 AA, and TB is pulling is 22.5 AB. So you have these 4 equations, and we can work out AA, and from AA we can work out V square is U square plus 2AS. So we can work out V is equal to 3.87 meter per second. So here on there is kinematics, and A is worked out by solving 1, 2, 3, 4 equations. These are 4 equations and 4 unknowns, A, AB, TA, TB. So we have just solved for A because that's what was asked. Thank you.